Hey all, Shemai Paub. This is Idna, and today I'm going to walk you through a HackTheBox Sherlock called Packet Puzzle. This is an easy Sherlock from Neetrox, where we're given a network packet capture and asked to pull this apart to identify key elements from the attack contained within. Let's get cracking. Okay, so here we are in HackTheBox Labs. I am just going to browse over to Sherlocks on the left here. We can see all the Sherlocks we've got available. I'm just going to search for the one I'm interested in, Packet Puzzle, and we can read through the scenario. You are a junior security analyst at a small Japanese cryptocurrency trading company. After detecting suspicious activity on the internal network, you exported a PCAP for further investigation. Analyze this capture to determine whether the environment was compromised and reconstruct the attacker's actions. So the first thing we need to do, as always, is to download the artifacts. I'm just going to move that out of the way of my head. We can either download straight to the computer we're using or copy the URL to the clipboard, which I am going to do because I am using Pwnbox to solve this. Use curl with a -L to follow redirects and then give it a name. So I'm just going to call it packetpuzzle.zip and then the path to the file. That should come down nice and quickly. We can see that there, and we now want to unzip that. So we're going to put it into a directory called Packet Puzzle to keep everything together and give it a password. So the password for Sherlock's is always HackTheBlue. You can also get that from clicking this button here. You can see that's put that into my clipboard, but that's where we are there. And we just want to extract that. Okay, so into that new directory, and we can see we've got a network traffic.pcap, so a network packet capture. I'm going to open that up in Wireshark and start to have a look at what's going on here. So when we have a network packet capture, one of the first places I like to start getting an idea of what's going on is in the statistics menu. Have a look at the endpoints first of all and find out what we've got here. So we've got, what's that? We've got 10 addresses here. One of those is broadcast. So we've got 9 different network cards involved in this, or certainly 9 different MAC addresses. 130 different IPv4 addresses. Seems to be quite a lot for a little challenge, but there we go. 3 IPv6 and so on. So here's all the TCP conversations and all the UDP. So you get an idea of the kind of things going on here. We can see there's going to be some 443 in here. Oh yeah, that's UDP 443. So that's the quick protocol. But inside TCP, we've got lots of 443, 80. So we know there's going to be some HTTP conversations going on in this. But that's a summary of the endpoints. We can get a little bit more detail by going to summary of the conversations. So similar window, but again, we can drill into the kind of conversations. What are those endpoints talking to each other about? So IPv4 traffic here, IPv6. TCP is where we can get typically a lot more information. I like to sort these into port order to see what's going on. We can see something fairly suspicious straight away. I mean, that looks like it's going to be a port scan of some kind. So 170.128 looks to be performing a TCP port scan of 170.130. And then there's also some HTTP traffic going between the same two hosts. We've got 1730 reaching out to the internet. And lots more stuff going on here. Oh, we can also see there's some, there's some additional traffic from 17.128 to 17.130. That's continuing that port scan. So again, we get an idea of the conversations, and this has already given us a little bit of a heads up of where we're going to get started. Finally, another place I like to have a look is, assuming we've got HTTP traffic, which it does look like we do, in statistics, HTTP requests. This can often give you a summary of what's going on by HTTP hosts. So it can give you ways to help sort of weed out potential noise. So in this case, it's unlikely that any of the HTTP requests relating to Microsoft are actually going to be things we're going to be investigating. Doesn't always rule that out, but we can pretty much know we're going to be focusing on a couple of these here. So 170.130 looks to be a PHP web server. That looks to be some kind of exploit targeting that. 170.128 is a web server listening on 9696, and there is some kind of GET request to fetch nc64.exe. Now, assuming that is nc64.exe, not just a file named that, that's the Windows binary for Netcat, which can be used for things like reverse shells and bind shells. So I wouldn't mind betting we're going to see some more of that later on. So we've got a bit of an idea of what's going on here. Let's have a look at our first question. What is the source IP address of the attacker involved in this attack? So if we come back to our conversations, we saw that port scan. In this one here, sort by destination port. This does look to be a TCP port scan. I mean, that is very unusual to see all of these happening in such a short space of time. So that leads me to believe that 170.128 is the attacker, 170.130 is the target of this port scan. Again, we can get a little more confirmation of that in the HTTP requests, which I just showed. 170.130 is a web server that looks to be being exploited here. 170.128, which was doing the port scan, is the thing that's hosting nc64.exe. So, and there's a GET request to it. So that's probably the target machine reaching back to the attacker's infrastructure to download some more malicious tools. So that makes me think that 170.128 is our attacker here. And it is. How many open ports did the attacker discover on the victim's system? So we saw the port scan happening. What we need to do here, think about, is the TCP handshake. So when a computer talks to another computer over TCP, the source will send a SYN packet. If the target of that packet is listening on that port, it will send a SYN ACK, so to acknowledge that SYN, and then the source will again send a final ACK. So that's the TCP three-way handshake: SYN, SYN-ACK, ACK. A good analogy for this is like a telephone conversation. So you might pick up the phone, dial a number. If the person answers the other end, they will say hello. So I've sent a SYN, which is the ring. They've said hello, that's the SYN-ACK, and I say hello, and that's ACK. And then we can start our conversation. That's the kind of dance that starts around a phone conversation, and that's the same thing that's happening in TCP. So with that in mind, when looking for, if we go back to our question, how many open ports did the attacker discover? It's only the open ports that are going to respond with that SYN-ACK. So we want to filter those out and find out how many of them there are, and then we will be able to get our answer. We'll know which of the ports that are actually the things of interest here, because the ports that didn't respond are less likely to be compromised. There's nothing listening on that, or they're blocked for some reason, firewalls or something like that. We will once again use the conversation summary as a quicker way to establish our conversation filter here. So we know that we want to filter between these two IP addresses. So when this is the attacker, so that's sending the traffic, 1730 is the responder. So actually it's the responder we want to see as the source of this, because it's sending the response back. So if we go to our IPv4, 20, there we go. So that will do this. So this is address A is 170.128. That's our attacker. Address B is 170.130. That's the target. So we can right click and apply as filter, selected. And I want to see when B is the source of that traffic and A is the recipient. And that is going to build us up a filter in the background. And now we can see all the responses from the target to the attacker. We can see a bunch of these in red. These are reset packets. This is basically where the port wasn't listening. So the attacker sent a SYN, and the responder can send a reset, or sometimes they won't respond at all. But that just closes off the conversation, as in there's nobody home. These SYN acts, these are the things we're interested in. These are the responses to open ports. We just want to see those, so we can expand the transmission protocol here, transmission control protocol rather, and in the flags, we want to filter for that. So again, we're going to right click, apply as filter, and select it because we want to add this to our existing filter. And that is just going to give us all of the responses to the port scan and any other traffic. There's also going to be other traffic that's going on in here. We can pull out the source ports here. So this has been added as a column. So what you can do, this column here isn't there natively. That's just part of my Wireshark setup. So I'm going to remove that just to show you how I put that there. I'm interested in this is the raw look. What I'm interested in seeing is that source port as a column. So you can right click any of these fields here, but I'm choosing source port here and apply that as column. And we can see that a little bit more clearly the actual destination of this. So we can count up the unique ports here and come to our answer. That will tell us how many ports we're actually listening. We can do that by hand if we like. We can also do this in tshark. So Wireshark has got a command line version, which is quite useful for. Here we go. It's quite useful for doing this kind of thing. Being able to you can do all the same kind of filtering, but then you can pipe it into the commands. So we're going to pipe it into some other bash commands to help us do that filtering and counting for us. So tshark is the raw command. We want to give that, so -r is the read this file in. We want to give it the filter, so the same filter we applied just now. So we could build this by hand here. We've already got this open. So this is the filter we are interested in. And let's put that in quotes. We could actually, let's just show that to start with. So you can see here, this is the same information we had in our raw filter here before I added that field. We can do some further filtering of that. We actually only want to see the source port. So to do that, we can add an additional parameter for tfields, telling it that we want to extract some fields, and then give it the name of the field that we want. So the field in this case for source port in Wireshark language is tcp.sourceport, and that's just going to give us all of the source ports. Now, using this, we can pipe this into other bash commands. So we just want to see the unique ones. We've got lots of multiple 80s in there. We don't want that. We just want the number of unique hosts. So we can pipe that into sort u. I realize my head is in the way slightly. So we can see source port u. Let me just move my head out of the way here a second. Right, okay, that's a little bit better. And we just want to count that up now. So wc-l, which will count the number of lines, because each of these are on an individual line. And we can see we have got 8. So there are 8 listening ports. We come back over to our answer, move my head back out of the way. 8. Okay, nice. Okay, question 3. What is the first open port that responded on the victim system during reconnaissance? Probably the best way to see that is back in our Wireshark. We've got the ports open here. If we sort them into port number, this will be in time order. So the first one to respond was port 22. So port 22, SSH, was the first to respond to the port scan. Okay, question 4. What is the CVE identifier for the vulnerability exploited by the attacker? Okay, so again, once in here, we can add to our field. We don't just need the syntax anymore. So let's have a look at, we can probably start to look for the destination. Yeah, we should. We've got our traffic the other way around here because we were looking for the SYN-ACK, but we want to see the source and the destination the other way around. So we want the request going from the attacker to the target. And I didn't mean to get rid of them, and HTTP. So it's just going to show us our HTTP requests. We can look inside of this. If we go to the HTTP here, we can see some. We can see straight away this is actually looking really, since that looks like it's going to be a PHP web shell, something like that. This is the post request that is effectively sort of has the exploit buried in it. What we can do, copy the value of that post request and just do some very simple research. And I say research very loosely because all we're going to do is Google this. Reject. So we're just going to post that in here and possibly just add in CVE for good luck because we know we are looking for a CVE identifier. Straight away, so we've got some hits here. So these all look to be pointing to the same thing, CVE 2024-4577. We can look at the Storm Center here. See if that's got any useful information for us. Yeah, so we can see this is pretty much what we are seeing here. So I believe this to be our CVE that is being exploited in this scenario, in this attack. Yes. What is the name and version of the vulnerable product exploited to get RCE? Back in our packet capture, we can start to follow these streams. So by right-clicking, choose Follow HTTP Stream. Because this is in plain text, this is not encrypted traffic, it's just HTTP, we start to see the actual conversation. So we can see here that the post request coming from, going to this server, this is the user agent. The post request contained this data, so PHP web shell, with who am I? Or maybe not web shell, but a PHP command running system commands, who am I? And then we can see the answer. So this is the web server is running as Christo on this, which I guess is the host name. Is a redirect happening. Where do I see 302? So it's redirecting to this. But this is it's running Apache 2458 OpenSSL, but we already know that this is a PHP exploit. The version of PHP that is running is 8.1.25. So PHP 8.1.25. Great. What is the username of the victim account? We just saw that. That's the account this has been run as, and the username is Christo. Number 7. At what timestamp did the attacker execute the command to gain their initial foothold on the victim system? So we can see here that this is where they are running commands. What we will do is go back to this filter. Let's just close this here. In here, you can see the command being run, or certainly part of it. Why is that opening up all the time? So they ran who am I, then who am I priv, who am I priv again, who am I all, pwd, print working directory. Let's have a look inside that directory, and then we can see a long PowerShell command. Again, it's probably easier if we could edit for any of these. We can follow the stream and see that full HTTP stream that we saw just now. But this is the one we are interested in. So follow HTTP stream, and we can see the full command here. Just to remind myself of the question, what timestamp did they execute the command? So this is the command that would have got them initial access. This is a PowerShell reverse shell. So you can see it's setting up a new socket over to 170.128, which we know is our attacker, on 4545. Sending all the buffer and the streams back to them. So this is a PowerShell reverse shell. When did that happen is the question. So this is our time here, but this is the default Wireshark format, which is relative time since the packet capture started in seconds. We need to change that so we can view time display format, and we want it to be this format. This is the closest to the question, the answer format that we need. And we can get this somewhere. There's a nice place to get this. I guess that's it. I'm looking to try and copy the timestamp here, and I don't know why I can't find it. I'm just being lazy, really. I could just type it in. 2025, January 2022. As soon as I stop recording, I will immediately remember how to do that. 0942, 094732. So 9:47:32 seconds on the 22nd of January. That is when they gained their initial access, or their initial foothold. What is the MITRE ATT&CK technique ID used by MITRE to gain an initial foothold? We've done this in some videos before. MITRE ATT&CK is an incredibly useful resource. It is a framework of all known tactics, techniques, and protocols by threat actors, and you can find it at attack.mitre.org. It's full of very, very useful information. Everything's stored in this framework here. Well, this is the MITRE ATT&CK framework. There's lots of other frameworks, but this is the one we are interested in here. Each of these are tactics. They're inside those are techniques. So all of these techniques are a way to form an attack chain. It doesn't necessarily go left to right. You can dot around here, there, and everywhere. But this is really interesting. Inside each of these is information around information about that, sub-techniques, if there are subcategories of that same technique, where it's happened before, who is known to do it, mitigations. I've likened it before to basically like the IMDb of cybersecurity, sort of offensive security tactics and techniques. So basically, who's running it? What do they run it on? What software is it buried in? Where have we seen it happen? It's very, very useful. We are here looking for the initial access vector. So that is in the initial access tactic. And there's only a few here really, so we can quickly rule out some of these. I mean, exploit public facing application is the one that immediately stands out as being the most relevant here. External remote services is more like if remote desktop is exposed or something like that. So this application is a website. It's intended to be public facing, and I would say public facing loosely here because we are dealing with internal IP addresses in this scenario, but that's likely just to do with how the scenario was made. This is still a web server that was attacked, so I think we can consider this to be public facing in the scenario we're actually interested in. Let's have a quick look at that. I'm not going to go into all of the details of this, but this is basically exploit a weakness in an internet facing host or system to initially access a network. That's exactly what we saw happen. PHP was running a vulnerable version, vulnerable to a HTTP post request with certain amount of data inside there, certain type of data inside rather, certain commands in the post data, and gave the attacker access. So this is the technique ID associated with exploit public facing application. And we can enter that in here, and that is number 8. What is the name of the malicious executable the attacker downloaded and executed in memory to facilitate privilege escalation on the endpoint? Now, if we come back to our HTTP filter here between the hosts, we see the very last one was a GET request from the victim to the target's web server to download nc64.exe. So I mentioned this earlier on. That is a Windows binary version of netcat, which has many purposes, but one of those is to establish reverse shells. So it's very likely that we would start to see traffic on a different port coming from the attacker back to from the target back to the attacker as that reverse shell is established. So they've used a PowerShell reverse shell to get the initial foothold. They've used that to go and download their own tools, and then we'll be running that to get a better reverse shell backup. So in order to see what's going on there, we want to find that traffic in here. We've got a HTTP filter on now. That's not going to do what we want. But we also want to flip these back again. So the destination of this traffic is the attacker, and the source is the target. And we don't need HTTP. We also don't need the parentheses. Not that it would matter, actually. Okay, so we've just got all of the conversations between those. If we go back to statistics and conversations, we can see just this filter. It's already filtered because we've got this ticked here. These are all of the conversations between those hosts. So, if we sort by port, we can see that port scan again. This time around, I'm going to sort by packets because when there's data being transferred, such as reverse shells, things like that, you get more packets. These 1 packets here, these are going to be a port scan. So we can see here, as expected, the target or the victim sent something back, 27 packets back to the attacker on 4545. 9696 was also used. That was where we saw the attacker's web shell was running on the attacker's web server was running on 9696, which is where NC64 was retrieved from. And then we see this 4545. That's the only one we haven't looked at so far. So we will use that and follow the stream for that and see what we can see. So basically here we can see, because this traffic is unencrypted, we can see the commands run by that attacker as part of their netcat shell. So we can see here just some initial enumeration, dir, looking up into the this directory, moving into Apache, having a look at what's going on there, reading the about, etc., etc. more who am I? We saw that earlier on as well in the PowerShell reverse shell. Moving into temp. This time it's getting netcat and saving it as time. So it's getting a new version of netcat this time, storing it in C Windows temp and saving it as the file time.exe. Moving into C Windows temp. Actually just checking it's inside C Windows temp already. And then doing an invoke web request. That's the alias for basically do an HTTP request to this URI. So it's going to get godpotato and specifically godpotato net4.exe, and it's going to save that as timeprovider.exe. Now, the potatoes are a series of Windows privilege escalations that I think started probably about 10 years ago. godpotato is one of those, but it is a privilege escalation tool. So that is what we're looking for here. How was the question phrase? What is the name of the malicious executable the attacker downloaded and executed in memory to facilitate privilege escalation on the endpoint? So that is looking for this. Oh, actually, that's the download. Do we see them execute that in memory? We do not. So this is where they're running it. And that's again where it's running it. But we don't actually see it. This isn't running in memory. That is running from the command line. So I wonder if this is just an anomaly with the question, I guess. I mean, this is the tool that's being downloaded. It's just not being run in memory. It's been saved as a file. If the attacker had piped that into IEX or invoke expression, that would have run in memory and it wouldn't have saved the file locally. But that isn't what we see here. Nevertheless, that is the name of the file associated with that tool. So that is the malicious executable, I believe. It is. Question 10. What is the command line used by the attacker while performing privilege escalation? Again, we saw this just now. So after downloading and saving the file as time provider, and then ran time provider. So this is effectively this godpotato. So this is the malicious privilege escalation thing. It's telling it the command to run after elevating the privileges is time.exe to this IP address, which we know is the attacker's IP address on port 5555, and send CMD shell. Now time.exe we see here, which is what this is NC64 again, another copy of NC64 saved as time. So I mentioned that just now, but just a refresher, that's what's happening here. So what this is looking to do is run godpotato, get system privileges, and then with those system privileges, send a netcat shell back to the attacker on 555. This is asking us for the command that was run. What is the command line used? So that is the command that is run to perform the privilege escalation. And then finally, the attacker failed to escalate privileges and was given an error. What is the error? So we can see the output here. Okay, it's doing all the kind of things that these potatoes do. I can't pretend to completely understand everything those exploits are running, but we finally see at the end a Win32 error 2. Cannot create pure process. Runs to MI to check if it worked. It did not work, so they run it again. And runs again. Win32 error 2. So this is the answer to this question, and I've just closed that. Apologies. Let's scroll straight back down to there. This is the error received. And that is question 11. Now, I'm interested to find out if we can find out what that error is actually about. So let's see if we can find anything on this. Is it a create process? Do we see that happening specifically? Yeah, it is, yeah. Cannot create process. So it's going to be this process, and we just got a forum type, so it can't find the file. So I actually wonder whether this couldn't find time. It looks like it got the, yeah, it did. It elevated to NT authority. So it got to network service, and then it got to system. Yes, it did elevate privileges, but it didn't run this part. So I'm wondering, was time actually not in that directory? It was. Basically, it looks like something went wrong here. It didn't take this command correctly, is my guess, and it couldn't find that file in order to launch the process as system. So it does look like the attacker was nearly there in this scenario. They just didn't quite get as far as they needed to get. But that does bring us to the end of the challenge. I must admit, it would have been nice to see this go a little bit further in terms of actually running that privilege escalation, see what happens next. But even so, that was still a nice way to run through some packet capture analysis and find out what was happening from start to finish at the initial access up to that privilege escalation point. So that wraps up Packet Puzzle. Thank you for watching. If you like, please do like and subscribe to the channel. If you managed to solve any part of that Sherlock in a different or better way, please do leave a comment. Please check out Sherlocks on HackTheBox. There are over 100. We release a new one every Thursday. Many of them are free. For now, diolch yn fawr.